Hello, everyone. Welcome back. We are going to be doing something a little bit different tonight. Unlike my usual coding thing, for people who've watched the last several streams, there's been an Enigma app that we started working on, Avalonia-based application. And that is what we're going to talk about more tonight. I actually have a guest, Izzy. For anybody who's watched the stream for a long period of time, the name should hopefully sound familiar. He has graciously agreed to come on here, and we will see if our technical difficulties continue or if things go smoothly. We're going to try it. It's going to be fun. First, a couple things really quick. We have .NET Conf coming up, or as I like to call it, Geek Christmas in a couple of weeks. So November 11th through 13th, think all things C#, .NET, everything that is new, the happiness that is going to be coming. Couple key things to note about it. One, it's free. You should sign up. It'll be streamed live on the .NET Conf website as well as their YouTube. It's underneath .NET. But then more importantly, I know him. I work with Benjamin. So he is a speaker. He is one of the lucky ones that got his talk accepted in. So very much looking forward to that. If anybody watched the stream where I kind of tried to nerd snipe somebody into saying, hey, it'd be really cool if we could take a failing pipeline run and download a unit test playlist file so that I could then just rerun those failing tests locally. Yeah, he actually went and did it. So Nerd Snipe turned into .NET Conf Talk, which is going to be awesome, and especially showing off AI and how he worked his way through it. For people who just can't get enough, there are a bunch of local .NET Conf events. So there may be one local in your area as well. One I will highlight is the one that we are hosting in Spokane, Washington. It is both in person and virtual. So if you are excited about all the things .NET, we have not fully posted our agenda yet for it. We're planning on doing that right after .NET Conf. So expect it around, I don't know, 15th of November to actually go in. But if you are interested in showing up, there is a registration link. Free for virtual attendees. In person, we're doing some food and whatnot, so there is a registration fee for that. But I think it's like 15 or 20. Don't quote me on that. Something of that nature. And then, because I am a glutton for punishment and feel like what's one more talk, there is a user group coming up in December about what is new in .NET 10. It's going to be a little more of what's new in C#, but the line between C# and .NET is blurry. Who knows, right? That gets kind of to be an interesting thing. So if people are interested in that, user group is coming up. Again, free online or in person if you are interested. Or you can always catch the recordings of it on Intellitek's YouTube if that time slot doesn't work because, different parts of the world. Speaking of different parts of the world, Izzy, are we alive now? Are we actually in and running? I have you. I'm thinking, maybe. Oh, I almost forgot. One other thing before I forget. Another great colleague of mine has started his own streaming, going through a lot of Angular development and Aspire. So .NET backend, Angular front end, Aspire, all the things. It is awesome. Dan is amazing. If you've been to the user groups, you have seen his face and have talked to him. He is now streaming as well. He needs more followers. So check him out. If you like it, give him a follow. It's well worth your time. Okay, Izzy, I delayed as long as I can.
Never mind.
Okay, sorry. I think I had your audio muted. Now you're hot. That is totally fine on the camera, by the way.
Merry Christmas.
Good to have you. Good to have you. For people who are interested, before I take away my screen, this is the GitHub repo that everything is landing in, where things are going. Izzy, do you want to give yourself any sort of introduction or how we got this project started or any of that?
Oh, I suppose I can just say that I'm just a very boring person day to day. Now, I work in a lot of very interesting projects, lots of government organisation type stuff. Um, I have a very keen interest in cryptography and World War II. And yeah, in my current company, they do a lot of STEM events,
Hmm.
and yeah, I kind of joined up, signed up, and I've been doing loads of STEM stuff. And you know, in the 5 minutes every day, I get ring about on my desk, and yeah, pretty much came up with the whole idea of what we're looking at here. So I've been trying to pull together as many people as I can kind of grab hold of to have some fun.
That is awesome. Yeah, and I very much have a soft spot for World War II history. My wife laughs at me every time I get sick, which happened, several weeks ago, where that's my go-to is I will start watching various World War II documentaries because that's what one does when you are sick. It's always been an area of fascination for me. So when you brought this up, it very much piqued my interest. So yeah, just to kind of catch anybody up who missed the streams before, we started a little Avalonia Enigma based application. Izzy, you want to give people kind of an idea of the relationship between what we've got between because we've got your breadboards and all kinds of fancy stuff there, and then the various kind of sections that we have in the repo that's out there.
Yeah, so originally the idea was kind of to kind of recreate the old Enigma machine, um, and of course that was very kind of mechanical, electrical. Uh, it's a glorified light switch, to be honest. Yeah,
Somewhat
ju-
complicated light switch, but
a
yes.
complicated, very complicated light switch, um, and of course it had its flaws in days gone by.
Mm-hmm.
Um, the Brits made their own version of it called the Type X. Um, that still had some flaws. I don't think during the war it was ever cracked. No one knows for sure.
Mm-hmm.
Um, but ultimately, I then kind of started thinking, right, well, how can I fix an awful lot of those flaws and how can I bring that into the 21st century? And of course, we have an awful lot more microchips. And I mean, we've got like the little chips just here
Oh,
that
hang on. Got to
that
switch my screen back to where you're pointing. But yes, keep
to where
going.
I'm pointing. Yeah. So on the little kind of blue items here,
Mm-hmm.
we've got nice little reprogrammable chips. So they're kind of FPGAs and CPLDs. So um, I thought it would be cool if we could use something like that in a modern day version. Um, yeah, and just kind of have a play. But then I was thinking, right, well, it's all good having the hardware. Yeah, let's make it educational and let's have an app to kind of show how the old ones used to work, where the flaws are, how kind of things all fit together, and just make it nice and pretty.
Yeah.
Yeah. Um, and kind of now the idea is kind of let's build this new machine that can pretend to be any one of the previous versions,
Mm-hmm.
and ultimately have this kind of app maybe on it. So I've also got, if I stick into my little screen, um, something along the lines of kind of this.
Okay.
It's a compute module.
Mm-hmm.
So it's a Raspberry Pi effectively, but essentially that is kind of the computer inside the device. Um, and yeah, just kind of thinking about actually having the app on the device as well, so you can actually, whilst you're there in real time, reprogram it to be the old version, yeah, the
Okay.
British version or the new version, or potentially making it so that people can actually play about with their own ideas, maybe, and kind
Mm-hmm.
of literally having it reprogrammable.
Yeah.
Yeah,
Well, because what we talked
yeah,
about a little bit on the stream last time is because before the original Enigma was just A through Z, and even just like some of the changes that we did before to allow arbitrary character sets, because it's like, okay, maybe we want to add, 1 through 0 or 0 through 9, depends on which way you're wanting to look at the keyboard, right? Of
Yeah, exactly. And you might even want to go for different character sets entirely. I mean, if you think Chinese, Japanese, and Korean, they're all kind of pictographs
right.
as opposed to ASCII characters. Yeah, I mean, wouldn't surprise me if somebody decides they want to use Klingon. Yeah,
Of
just
course.
yeah,
That's
as you
that.
do.
I think once we get this working, we should absolutely add Klingon as an extra kind of built-in set because that just seems epic. Yeah.
Yeah, so that's kind of the idea, and yeah, I want to try and kind of make it modular as well. So from the hardware perspective, so you can actually change out parts, which would be kind of cool to let people kind of um, yeah have a go at maybe building their own custom kind of components. So maybe the keyboard, maybe they want 40 characters instead of what I've got at the moment, 36, or
Mm-hmm.
yeah, maybe they want, I don't know, a full QWERTY keyboard or QWERTZ keyboard as it would have been back then.
Yeah. That is very true. Oh yeah.
So
Okay.
yeah,
So for anybody like I haven't seen a lot of this hardware yet myself because I mean you teased me with some pictures last week, which was kind of cool. Um, I guess maybe we should go through really quick for people unfamiliar with kind of how the old Enigma machines worked. Is there was often a pair of people operating them when it came for encoding a message. One person's typing on a 26 key keyboard, for lack of better words, and each time they press a key, a light lights up on a corresponding set of lights for each of the letters, and then somebody else would be jotting down which lights lit up, and that was your encoded message. Each time you press the key, the what's the right phrasing? The circuit, is that the right way to say it? Gets completed.
yes, yeah, it'd be the circuit is yeah. So the key is essentially the light switch.
Right. And then
Yeah,
light obviously on the other side. But the circuit ends up going through a set of rotors and then hits a reflector, bounces back through those same set of rotors into a plug board that might further remap which light goes to each key. And then making the complication even more complicated is the rotors then rotate on each key press. So knowing that initial state of which rotors and what kind of combination of remapping was occurring on the plug board was kind of the I guess pre-shared key is kind of the fundamental idea with that, right? Because however
yeah.
they
It's
were going
essentially
to set
yeah.
that up.
Yeah. It's a symmetric kind of encryption.
Right.
Very loosely speaking, it's very much kind of based off of the Caesar cipher type stuff.
Mm-hmm.
Um, but yeah, you'd have the types of rotors. So I think the original, so the very first kind of Enigma machine had, I think, the possibility of 5 possible rotors, of which you would use 3
Mm-hmm.
in a given order. So that's kind of your combination lock. And then you had the setting on the plug board, which was just then a manual. You can map any key to any key because all the rotors were, yeah, they came out of the factory set one way. You couldn't change them. That
Mm-hmm.
was kind of the manual step, just to complicate things.
Right.
And the plug board, I think, was actually used twice. It was used, uh, so you go from the key through the plug board,
Oh.
then into the stator, then through each of the rotors, um, through the reflector, back through all the rotors, back through the plug board, then
Mm.
into the lamps.
Okay.
So yeah, it was a very complicated bit of wiring.
Right. Okay. So then I guess you've got all of the plug board stuff there for the hardware because obviously me, I just write software to simulate real stuff, but you actually have real stuff. So I guess you want to walk me through kind of all the cool stuff that you've got going there.
Yeah, so I've got a couple of things. So I mean, the main part I've got is kind of my big breadboard. So I've kind of got on what is to me the left-hand side. I'm not sure how it shows on screen. It's probably flipped. But
Yep.
kind of down this side with the buttons. This is essentially my keypad with my 36 different buttons.
Okay.
So initially that then goes through this kind of first blue board, which is my first CPLD, which kind of encodes it into effectively a binary number.
Mm-hmm.
And that's what's kind of shown on the first 6 segments of this little light bar.
Mm-hmm.
Um, in order to mimic the kind of the rotation, I actually would have here is the EMMC, an EEPROM, sorry. So
Mm-hmm.
it's essentially one of these little chips here. So that normally sits here. I've got it currently plugged into a Raspberry Pi so that I can try and program it because I haven't done that yet.
Okay.
But essentially, this area here basically mimics the rotor
Mm-hmm.
or a rotor, which then would go into the second light box that kind of shows how we've scrambled the numbers from one to the next. And that's just kind of the example of getting through from the keyboard through the stator into a rotor, out of one rotor, and then it would go back into, and that's what the second CPLD is going to be for, and that is effectively to decode, which would go through a plug board, which I'll tell you what, if I just move the camera, it's probably easier, is this other one over here.
Okay.
So this kind of mimics the idea of the plug board. So we've got 2 plugs.
Mm-hmm.
I mean, very rudimentary kind of idea. So at the moment we've got kind of 2 lights on. If I unplug, you'll see one side is completely disconnected, the other one is connected to itself.
Okay.
So you've only got the one set of lights. But if I then unplug this one, they're both kind of then mapped to themselves. They have. I probably should have put the lights a little bit further apart to make it blatantly obvious which ones to wear.
Hey, that works.
But yeah, if I plug them, as soon as I plug them in, it's effectively just remapping
Mm-hmm.
the 2 endpoints. That's kind of what the plug board would be. Yeah, and then like I say, it's pretty much then the exact same thing then coming back the other way.
Mm-hmm.
So yeah, so essentially I have kind of 2 setups of the encoder decoder. So I have one which is from the keyboard essentially into the rotors. I then have another one which comes out of the rotors, which would be where the reflector sits.
Mm-hmm.
And that'll kind of then decode. It's kind of the opposite way around. It does decode and then encode.
Yeah.
So acting as the reflector.
Interesting. Okay.
Yeah, I mean, it's probably easier to show. You've got my screens. Let me. So
Oh yeah. Okay.
if it comes up there, so it's essentially just this is my kind of CPLD. A couple of little power rail bits and pretty much just the different connectors to go to the different places. But
1 second, Izzy. Let me got your screen being slightly cut off. Let me just adjust that real quick. Gotta just go into here and let's see here and share there and oh yeah. Let's see. There we go. Something more like that. Okay. We're good. Now I got your whole screen.
cool. Yeah. So like I say, I've got a very basic kind of circuit. I mean, from an electronics point of view, it's very simple. It's a
Mm-hmm.
glorified light switch. But but yeah, kind of the brains that I can kind of program is in this CPLD, and it's really just kind of connectors. So I've kind of gone for the same sort of connector you'd see on kind of a Raspberry Pi, kind of your 40-pin headers, um, and that essentially will go out to the spade connectors, which will go onto where the jacks are, or onto kind of the keyboard. So I've got, I'll go back to my camera. So I've kind of got this little thing, which is what I'm using for the keyboard. It's like literally a mechanical switch type thing,
Oh wow.
if you can see that.
Yeah, I can. Wait, so
Um,
why does if that's just a simple mechanical switch, just why so many connections on it?
it's possible to use the switch both in kind of a normally open and a normally closed kind of
Oh,
way.
okay.
Um, so one of the reasons I kind of went for that switch is because people may want to test out different variations of how the switch mechanically works, whether they want to have the system. Sorry, in electronics, you kind of have either your voltage rail, or you could ground everything. And there are different chips that work different ways depending on um, how you might want to do that. So essentially, your middle pin is kind of where your power comes into the switch,
Okay.
and then if it's depressed, your top pins are the ones that are actually connected,
Mm-hmm.
and if it's pressed, then the bottom pins are the ones that are actually connected, and you could actually have two circuits running off of the keyboard. So
Okay.
what you could kind of modularly do is actually have the key press does or uses one side, maybe
Mm-hmm.
to control motors, say to turn the rotors, but then your other side would maybe go back into another circuit that would be your decoder, encoder, maybe plugged into a Raspberry Pi to do something else.
Okay.
Yeah. So one of the other ideas I was playing with is actually having kind of a Raspberry Pi between the actual keypad and the CPLD encoder, whereby you could actually type in, say, a whole message or phrase first, and then the Raspberry Pi might do some kind of pre-encryption, or something along that lines, before then encoding what would actually then be binary or a base 64 type
All the way.
character set. So you kind of get this kind of multi-layered um, approach to kind of encoding a message. So you could use your normal kind of asynchronous cryptography kind of
Gotcha.
on the message beforehand, and yeah, and people can kind of play about with that, and that's kind of the idea of it all being modular and going kind of overboard on what possibilities there might be at each stage.
I think you said it perfectly right there. Going overboard. Like when a software engineer does this, they say that we're over engineering it, but you've now done that equivalent with hardware.
Yeah, well, I mean, it's very much like trying to write a library, really. I mean, yeah,
Mm-hmm.
when you're writing a library, you need to kind of think about all of the possible ways that somebody might want to use this particular thing, and make every single thing available and easy to use.
That's true. That is
And
absolutely true. This
the
is just the
exact same
hardware
thing
equivalent.
exists for the hardware. Yeah,
Yeah.
yeah.
That is pretty cool.
Yeah, so that's kind of the kind of fundamentals. And like I say, I wanted to try and make it modular, but at the same time, a kind of a learning experience. Hence why the kind of the application, and it'd be kind of good to have kind of involve all the history of how we kind of went from effectively the Caesar cipher up to more modern day kind of cryptography. And a big part of that was kind of the Enigma machine, and yeah, how Alan Turing and his team back in the day. With a couple of Polish guys, if I remember rightly, actually managed to crack how Enigma worked. And it's a really interesting story. I mean, they made a film out of it.
Yeah, I was trying to look up the name of that because it was only what Imitation Game. That was the one, 2014. Boy, I was gonna say 5 or 6 years ago, and I would have been way off.
Yeah, I think they actually made a couple of other films as well. I mean, if I remember right, it wasn't the one of the very first DVDs, probably showing my age, was like U571. That was all about
Mm-hmm.
submarines, and the whole task was for them to try and steal an Enigma machine, if
Yep.
I remember rightly. Yeah, back in the days when DVDs were a thing.
Yeah. Absolutely. I remember watching that and just absolutely loving it. And I'm trying to remember. I don't know. Was U571 actually based on a real story, or was that just for some reason I had in my head that it was what do they call it? Historical fiction.
I
But
I think I think it was based on a mission that was supposed to happen. I
okay.
don't think it was an actual real kind of true life event thing
Right.
dramatized. I think there were plans. I think there was back then. I think there was like probably 5 or 6 different plans. It's kind of depending on which way the weather,
Yeah.
the wind blew today. Depends on which one we're going to do, and
Right.
hence things like D-Day. And
Mm-hmm.
it's exactly the same kind of thing as that. That they had like 5 or 6 different plans in place, and it just so happens, look, the weather's going to be like this, so the clouds are going to hide our
Mm-hmm.
entry. Let's go down that way instead of that way.
Right. Yeah. No, it's absolutely fascinating to me. Love every bit of it. Um. Okay.
Yeah.
So I guess then I just realized, just to clarify a term for people who may not have heard it before, the idea of a Caesar cipher is one that you've probably done before in a lot of cases where it's, we've all kind of like replaced A with one, B with two, and written kind of out a code of that nature. That's a very kind of basic Caesar cipher, if I'm not getting my
Well,
terminology wrong.
so the Caesar cipher. I mean, if you think, I think you usually do it in like I don't know what kind of, so it's like lower school when I was there. Um, I mean, we used to have the 3-tier system, so lower school. But
Mm-hmm.
it's basically where you have um, effectively 2 sets of alphabets, A to Z,
Uh,
one above the other,
mm-hmm.
and literally you slide one along. So your A now becomes the Z, or
Right.
yeah,
A gets B, B gets C, all the way
yeah,
around.
yeah. And it was a very kind of a linear cipher.
Yeah. My wife and I actually
um,
just did I don't know what you call it, a in-home escape room type situation, and they actually had one of those. They had the dual discs for doing the cipher,
yeah,
and it was one of those. I saw it, I was like, I know what to do.
yeah. So that's kind of generally what the Caesar cipher is, and then um, I can never remember the term. There's another one which is kind of based on a given text, and what you actually do is you get numbers, and usually the
Yes.
numbers represent like the page of the source text, the line on that page, and then the character within that line, and
Right.
various variations of that. But
Mm-hmm.
yeah, there's kind of a little bit of that kind of comes into it when you think of the Enigma machine, because of kind of, you think about the rotor settings. You kind of got, well, which page are you on, which rotors have you got, yeah, which line are you on, i.e., which way round are the rotors connected, and yeah, it's kind of a combination of all those kind of very similar different cipher ideas, kind of all
Mm-hmm.
rolled into one, which is why I find it so fascinating.
Right. And remind me, I feel like I read multiple different things, but how did they actually communicate like that initial rotor state as part of sending the message? Was that just something that was predetermined ahead of time?
So that was one of the flaws in the original Enigma machine. So the actual settings were sometimes it was communicated by mouth, yes, so just verbally.
Mm-hmm.
Sometimes it would be in a previous message would kind of at the end of the message would kind of have um, some details about what the next
Mm.
day's settings would be. Um, yeah, but most of the time it was all written down on bits of paper and handed between each other.
Got it.
Yeah, so um, and normally they would get like a week's worth of ciphers up front, so you'd have next week's worth in your back pocket ready for the start of the week.
Right. Which is all
Um,
well and good until somebody manages
so
to nick those papers.
exactly, yeah,
Okay.
yeah. But I mean that's kind of how the original um, kind of one was kind of decoded essentially. Is they would get all the rotor settings because you know one German lying in a ditch probably had the code in his back pocket type
Mm-hmm.
thing. You know, generally speaking. Um, and yeah, it would just be, well, now I know how the rotors are set. Now all I've got to figure out is the plug board. And yeah, and that's kind of what Alan Turing and his team were kind of figuring out and kind of working out the maths for. And that's kind of how the boom kind of came about, which was their
Right.
great big machine that had a ton of rotors all mechanically going at once to try and determine various different states. And they kind of use things like that to figure out, potentially some of the unknown rotor
Mm.
configurations, but it also helped to figure out what some of the plug boards were. Yeah.
So, do you know how that original machine actually managed to break Enigma? Because I was reading through on how many possible combinations there were, and the numbers got astronomical. And I wasn't really clear on, like, if I had to go through and break it, I was like, oh boy, thank goodness I have modern computing because there's way too many combinations to even think about.
Yeah, so there are a couple of kind of mathematical um, kind of ways to figure it out. You can actually kind of do things on effectively a sheet of paper. Um, there's another YouTube channel, it's like Computer Files.
Yes, computer file. I believe I've seen it before.
Yeah, and they actually have 3 or 4 different things that actually go through how you can kind of break the Enigma codes. They have quite a
Okay.
few. They have quite a few kind of things on. I think there's
Your
three
father
different
knows about saving money.
Oh,
kind of people where they kind of dig into it. And yeah, that's quite an interesting kind of eye opener as to how they kind of did it. But I mean, generally speaking, they always, when working on these things, you kind of know, well, every day there's going to be a weather report. So at some time in the day, whatever the message is, the word weather is going to appear. Yeah,
okay.
yeah, and because they knew certain times of the days had very specific messages, they could kind of use that to guesstimate how close they were in ciphering and kind of reduce the number of permutations that they actually had to run on the boom,
Okay.
because you could quite easily write off several of them just based on the fact that none of these are ever going to produce the word weather.
Right. No, that makes sense. Yeah, because I guess even given that, if you know something about the domain of what the data is going to be, even being able to reduce that out makes a lot of sense. Okay, cool. I find this immensely fascinating.
Me too. Yeah.
So,
When I'm not trying to do my day-to-day work, I mean that's like literally I can quite easily turn up to the office at 6 o'clock in the morning and leave at I get told off for leaving any later than 8 o'clock in the evening.
hmm
Yeah. But I do that quite often, and it's just because I get in, I start tinkering with all this sort of stuff and having a little play, and then I remember, oh yeah, I've actually got to work now.
oh yeah, there's actually like real things that need to happen here. No, that I think for a lot of the best engineers that I've met, they all kind of have that same I don't know if curiosity is the right word, but they get this fascination of certain areas and you get in there like I know I get yelled at for forgetting to eat meals because I've just like I've hit coding nirvana and it's like no, my brain is in the right headspace for this. I'm doing this now. Like while I've
Yeah,
got my brain there, I need to leverage this.
yeah. I find it very difficult because yeah, I mean, software is my kind of main area of interest, but um, yeah, it's like you get on something. It's like, yes, I know what I'm doing. I just need to finish. Let me finish.
Yeah.
Yeah, and I've had to go and steal the spare keys for the office a couple of times. Just say, let me close up. I'm not done yet.
Oh, I totally understand that. If software is kind of your main area, how did you get into this? Like, where does the line kind of end for you between software and hardware? Because I realize it's a very blurry line at times.
Right. So I kind of I suppose it all started when I bought my first 3D printer. Um, yeah, I've always been kind of a software person, and that's kind of my bread and butter is the software side of things, and
Hmm.
mostly back end services or kind of simple UI stuff. Um, but then yeah, I I saw a 3D printer going really cheap one Christmas. Decided I'm going to buy one of those, and so I bought effectively the Ender 3.
Yeah.
Yeah, and watching loads of YouTube tutorials, it's like, oh, I can customize this. Oh look, I can change the operating system on it, and I can, yeah. So I converted it from Marlin to Clipper, and now I've got a Raspberry Pi. So what can I do with a Raspberry Pi? Yeah, and I just started digging an even bigger hole for myself, and
Yep. I
yeah,
mean,
and I just got into that kind of bit where I started working with
okay.
microcontrollers, and yeah, it just kind of spawned. Yeah, it's a snowball.
Yes, it
I started at the
absolutely
top of the
is.
hill and I bought a printer, and now I'm halfway down the hill collecting houses and trees and fences on the way.
Yeah, no, I completely agree. Like my wife one year, she got me an Ender 3 as well, and I didn't realize what I was getting into when I opened it. Because you're right, it absolutely is a like the 3D printer is kind of like the gateway drug into a lot of we'll say maker area stuff of whether that be you go down with your Raspberry Pi breadboard stuff or even just CAD and modeling and all the stuff that can go along with it very quickly.
Yeah, I'm kind of in all of it. I must have at least 7 segments of my brain, just one lit up with each of the various different facets and areas of different things, and so many ideas just going everywhere.
Yeah.
Yeah,
Is the
it's
is the
just
plan for this Enigma machine to actually like build out I guess what is your vision for what the end physical state looks like?
so the end. I want to have a fully kind of a full replica of effectively the Enigma machine. So the box, everything,
Okay.
all there, um, and literally being able to just kind of unclip each part and maybe replace with a slightly different flavor. You know, like I say, the keyboards, and maybe get a Klingon keyboard and stick it in there, and
Just for kicks and
um,
giggles.
yeah, you know, and I want it to be very kind of modular. And again, it's just kind of that learning experience. It's kind of here's what it would have looked like in World War Two,
Right.
end of World War One type era, and but now I'm going to bolt stuff on the side, and now it's the Type X, and it
Mm-hmm.
works slightly differently, and now it's my brainchild, which is let's make it really complicated and whatever, but also at the same time just kind of maybe running some kind of sort of challenges. Who can build the best, you know, um, synchronous encryption machine?
Mm-hmm.
Have at it, configure it how to your heart's content, and then run kind of challenges. What's today's encrypted message? Can anybody crack it? Just just for fun.
Right.
Just,
No, I think that would be absolutely awesome. Like I've been poking around just seeing different things, and clearly my Google search history has now been poisoned because I've started to get a lot of different Enigma things popping up on social media and whatnot. I'm like, okay, clearly somebody has leaked that I'm interested in this and bringing it through. That like, and that honestly makes me kind of excited to actually see something like that get built, because that would be awesome. Hopefully, I get over to your neck of the woods at some point so I can actually lay hands on it, because that would be pretty cool.
Yeah, well, if we get as far as actually making the whole thing, and getting it all up and running in a box, yeah, like I say, very similar to that picture you got there.
Yeah.
Yeah, yeah, that's literally. I want it to kind of look authentic. Here's
Mm-hmm.
the thing: the only difference is kind of physically the internals, which is why I wanted that kind of application. Is kind of we can actually show what the internals would have been, but
Yep.
physically in our box, we've got all the CPLDs just so that we can, we can kind of physically change the mechanics under the hood,
Yep.
as it were. So that's kind of the idea. But then you can kind of get an idea of all the different flavors, but it still looks like the original machine. Yeah, and can work that way still.
Yeah.
But
And
just kind of showing how some of that kind of mechanical stuff would have worked. But yeah, we've kind of
right.
replaced that with the electronics.
Right. Yeah. We're no longer dealing with physical wiring anymore. We can do your fancy breadboards and EEPROM chips and reprogram things to
Reprogram
remap
stuff,
stuff,
yeah.
which is something that unfortunately Alan Turing did not have at his disposal. But
No, sadly not. But
yeah, that would have made his life a little bit easier, or at least prototyping a lot quicker. Um,
yeah, well, if they had computers, then the Enigma machine probably would have been broken in like 30 seconds.
yeah, when you can rip through things that fast, though, they probably would have been using something also up to par for that. So yeah,
Vacuum tubes, maybe.
yeah. Well, cool. What else on this did you want to go over, Izzy? Because I think this, like I said, this is looking really slick to me, and I'm excited to help out on this. I think, at least for me on the software side, what I want to play with next is figuring out the 3D rendering of that to try to make a pretty picture. I
Oh
think.
yeah, so I suppose the other kind of things, just to I suppose as a quick thing. So you've seen kind of I kind of showed um, the kind of the circuit diagram, which is one part of the board. Like I say, we can kind of go through the various stages where I've actually, if it's going to load,
Oh wow.
yeah, I actually build the actual PCB and the layout for where all the components are going to go, how small it's going to be. I mean, just as an idea, this is roughly the back half of a Raspberry Pi. I mean, if you take the Raspberry Pi and cut off like the USB and Ethernet header bits, it's about that sort of size.
Mm-hmm.
But I can also actually then generate the models for those as well. So we can kind of see it in our 3D space, and I can actually print it off if I wanted to. Yeah, kind of get an idea of where things do, and hence the 3D printer. That's kind of been going making little parts just to represent things and how big they are.
Yeah.
Just to get an idea of how I'm going to fit things inside the box and where things are, which I find is quite cool. But then we've got the actual software side of those kind of chips. What I've been building up is very much kind of the visual logic of it before I actually drill down into um, doing what would be kind of VHDL, I think it's called,
Mm-hmm.
very very logged stuff, which is kind of the code that would go on the CPLDs.
Okay.
So I mean, you can get a rough idea. I've tried to
And this is taking me back
simplify.
to my old electrical engineering classes in university.
Yeah, and that's
Been.
kind of very much where it is. It's kind of here's the logic. Yeah.
Mm-hmm.
So I mean, I've kind of made my own encoder block. Yeah. So kind of under the hood here, if I open up the actual encoder, so this I think was the thing that I kind of showed you brief picture of
Oh yeah.
last
Okay.
week, and this is like how do you map all of the pins? So each one of the keys from the keypad.
Mm-hmm.
And in this case, we've got 36. Yeah, and how do we make those into a binary number that's only got six outputs?
Yeah. Can you zoom
Yeah.
in a little bit on the right hand side on the like those logic gates? Just for anybody who hasn't seen this type of pattern before. Like for people who haven't done like electrical stuff, this is the equivalent of programming effectively if statements inside of there. Because if I remember right, that's a NAND gate, or is it just a? I think.
These ones are OR gates.
Okay. And
Um,
this is where
so
I'm going from memory.
yeah, so the ones with the little dots. I mean, the little white kind of dot usually kind of in my head, I probably have it wrong, is essentially that it is activated by being pulled to ground, basically. So
Okay.
an off is true,
Mm-hmm.
and then the or is just any one of these on the inside of that line need to be true in order for the output to be true.
And then
And sometimes like kind of this one over this side, you've
mm-hmm.
actually got the opposite. So all of these need to come in effectively as on or one, but then the output, if any of those are one, the output is zero.
Got it, which is your signal key that you have there.
Yeah, and this one's got the dot on the output, so the output is then inverted. So
Mm-hmm.
that's effectively an inversion. So
Right.
if it hits kind of the top of that little orbit and
Mm-hmm.
it's true, the dot makes it false, and therefore the actual output of that is false. But yeah, it's all a kind of built up logic gates, and that's basically what the CPLDs are. They're complex programmable logic devices.
Yeah.
So you
And
just kind of bolt all of these together, and yeah,
yeah, I think that was the most amazing part when I took the engineering course at university was finally the light bulb moment when I was like, oh, like computers are just I don't want to say mechanical machines, but kind of mechanical machines, right? The logic gates are the equivalent of my, if statements or Boolean expressions, and all these things are is chained Boolean expressions in a lot of cases,
exactly
albeit
that. Yeah,
very
yeah,
complicated in some cases, but it's like, and then, with the gates shrunk down to the size of an electron microscope resolution. Rinse, repeat.
yeah, yeah. Yeah, that's kind of all they are. I mean, you think about it, you can build up kind of chips with logic, and it's just kind of the how you connect those gates together, all those bits together. It's just, is it an if? Are we inside the else statement?
Mm-hmm.
You know, it- that's all code is under the hood. It's just branches of where is this going now. It is just all logic.
Yep.
Yeah, exactly the same as what's in the electronic circuits. So they're very similar. The only real difference between software and hardware is once hardware's on the board, you can't change it.
Exactly.
Yeah, so
Software's cheaper to
that's the only real
change,
difference.
usually.
Yeah, I mean, so some of my previous project managers um, used to have this kind of idea. Well, yeah, if we get the hardware wrong, we'll just fix it in software, which yes can be done a lot of the time,
Maybe,
unless
yeah.
the issue with the hardware is you just didn't put a line in somewhere.
Right. Yeah, it's like you can't
Yeah,
get there from here.
yeah. Unfortunately, I can't bridge that physical electron gap with code.
Right. Yeah, there's only so much I can do. I can tweak inputs, tweak outputs. I cannot magically connect wires that aren't there.
Yeah. Um, but yeah, like I kind of said before, so I kind of when I started delving into all of this and whatever else, that's when I kind of moved to the company that I work at now, because I started really getting involved in, how does the Raspberry Pi work and how does the electronics work? And where I was, I didn't have any kind of projects to work on that were very hands-on with electronics, and that's what I wanted to start getting into.
Mm-hmm.
So where I work now, they're actually a manufacturer.
Okay.
Um, so yeah, so I have a lot of electronics geeks around me that I can ask very silly questions of, and sometimes I get things very wrong. Sometimes I get them less wrong.
Hey, there's something to be said though about being around that kind of environment when you've got the people there with that kind of knowledge and passion for it. Like that makes all the difference. We talk about like university students always trying to get internships, on their summer breaks and whatnot. And some people think it's about the learning, and I think it's really more about connecting with people who are in that field or area that you want to go into. Because I think that kind of spurs on that curiosity or learning for people in a lot of cases.
Yeah, and it's all about kind of sharing those kind of experiences and how everybody learns. I think because we all learn in different ways, but
Mm-hmm.
I mean, you look at a bit of code, no matter how you read it, it still does the same thing. And
Yep.
circuit boards are exactly the same thing. Doesn't matter how you read all the different kind of component icons and links and traces and yada yada. Um, but no matter what kind of viewpoint you look at it from, that circuit still does the same thing.
Mm-hmm.
And no matter how kind of experienced or inexperienced you may be, you can look at a circuit and you can walk through it logically in your head with your finger on a bit of paper. You can follow all the lines, connect all the dots, and and I have a lot of light bulb moments where I'm like, well, how does this thing work? And you print it on a great big A4, what are they now? A2 sheets, um, massive bit of paper on the desk.
Mm-hmm.
And it's like, right, well, that line goes from the top left corner all the way through these things, yada, 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 all the way down to the bottom right. Click. Oh, I know what that's doing now.
Yep. Yeah, I
And
mean,
so sometimes I do the same thing with code. It's like, what the heck is this function doing? Just print it
mm-hmm.
out on a sheet of A4 paper, plenty of gaps between it so I can write my little squiggles and my notes and sometimes kind of work through the logic. And
Yep.
it's the same process, just a smaller sheet of paper.
Yeah, exactly. Or in my case, I often that's exactly what I reach for a whiteboard for is the idea of being able to kind of write it out and draw pictures of kind of mapping the flow through of functions, variables of like how did we get there from here? Like that's one of my favorite things to get is production level failures or bugs where all you have is kind of a stack trace. It's like, okay, I can see what happened, but how did I
How did it
actually
get?
get
Yeah.
there? Like, and that's one of the I enjoy those problems because they're very kind of deductive reasoning to figure out. Okay, well, I can clearly see that we got to this, theoretically unreachable point of code. How did I get there? Right? Like, there's clearly a path that gets me there. I just need to find it and try to kind of reverse engineer out what that is. And then when you find it, then it's like, oh crap! Now how do we fix it?
Yeah,
But
usually that's one of those cases where it's oh, I went through that type of exception which I'd forgotten about
mm-hmm.
from, past me was an idiot and, didn't handle this one particular use case, and that's just fallen into some kind of catch somewhere which it shouldn't have done, and
Yep.
ends up going back round the cycle, but the wrong way.
Yep, exactly. I had a colleague message me earlier today, even with a problem of, hey, so, we've got this ticket we're working on, and, we said we were going to run this function when the collection was empty, but now we've added this filtering, and now the collection can be empty for like these three other reasons. It's like, oh, crap. You're right. That is a problem. Um, let's talk tomorrow. Like that, now we have to actually try to figure that out. And I think that's the part that people always forget. Like in some ways, I find this like electrical diagram you have simpler to work with because you could just follow the lines. Whereas it sometimes feels like because code is, I don't know, I don't want to say quicker and easier, but you can generate a lot more of it very quickly, or at least I can because that's my expertise. And it feels like it's easier to get yourself into a situation where you have the spaghetti lines and they aren't all just these nice crisp straight connections in all the cases.
Yeah, so sometimes I like to try and boil some of the kind of complicated code that I do down into very kind of similar representations here. So,
Mm-hmm.
yeah, like you were saying earlier, I mean, if you've got an if, then yeah, there's kind of an if block, and you'll have however many things coming in and going out, and you can kind of almost visualize it in a very similar way to this kind of logic diagram here. Um,
Yeah.
and for some of the complicated stuff, that's kind of what I do, is kind of draw it to simplify it. But again, with lines that kind of go, and you can then see where am I missing a line, or where have I got a line that crosses that shouldn't.
Mhm.
Um, and sometimes kind of taking it back to absolute basics, um,
Yeah.
which is very difficult when you've got maybe 1,000 lines of code
Hmm.
spread across maybe 20 modules that all kind of interact, and you kind of have to have these kind of top level diagrams of how these things interact. Um,
Yeah.
so yeah, most of my time, um, and annoyingly at the moment, has been very much kind of dumbing down and drawing out those kind of sequence diagrams of how the existing code works, because hey, we can't build it anymore for some reason. Now I've got to
Yeah.
go and reverse engineer it. So how do I do that? Well, yeah,
Yeah. I
build up this
remember
kind
there
of logic.
there was a project I was on where they had a very complicated auth flow of there was like 3 or 4 different ways for somebody to kind of authenticate into the application, and the way they interacted and what each of those authentication was, because some of them you got different update checks and someone's got different permissions in this case, and all the different kind of permutations of those together. And I remember at one point, I think we had gotten like 4 or 5 bugs in the area, and I was just fed up with it. I'm like, okay, stop. And I spent 2 or 3 hours just kind of drawing a data flow diagram through, and then I think probably another hour walking it through with kind of the leads and the PM of going, okay, here is how we are getting through all of these states. Does this match? And they're like, oh, because I think it was a light bulb moment for a lot of people because they all just assumed, well, of course the user just logs in. It's like, no, no, the user does not just log in this app. That is not how that works. It is a lot more, especially once they saw all of the components and the pieces and how things were working together. I think it was then the realization of, oh, now I understand why when I ask for one small change to this auth flow, it's not one small little change. It's like,
Yeah,
correct. You see all
it
the lines and
ripples.
the boxes and how all these things connect. Like, and I think that often does get missed, like you said, taking it back to basics of following it through of where it can go. That definitely is something that gets missed at times, even by me.
Yeah, I'm often missing. Kind of usually it's like one very subtle little thing that I've kind of just skipped. It's like, yeah, I've got this diagram. I've recreated it over here in .NET or Java or whatever.
Mm-hmm.
And you go to run it, it's like, why is the output different? Something's wrong.
Yep.
And yeah, and it'll take me weeks just to, oh, there's like a 1 there instead of a 0.
Mm-hmm.
And it's always just that one little significant switch that you could just kind of forgotten about.
Yeah. Yeah.
Yeah.
No, I even this week I was traveling at a client's office, and there was me and my boss got roped into helping with a problem on a system I'd never seen it before. This was my first time even hearing about this system or the problem, and we both sat down, and it was one of those. It felt a little bit like going back to basics, because it's like, hey, we aren't seeing the numbers we expect here. It's why. I'm like, I got no idea. But it then started going back down to that. Okay, well, let's work backwards and follow through the data flow. Okay, the query is running, the query is returning results. Okay, we got good data up to this point. Okay, well, where are those results going? Well, they're going over here. Well, why aren't they coming out the other side? Oh, it looks like we've got some error here. Okay, well, why is that thing erroring? And just kind of one step at a time, working the way through. Like, it was kind of fun. Now, admittedly, it was a system I was completely unfamiliar with, so I was learning as quick as we were debugging, but it never felt like we were completely stuck. We always had, oh, well, let's go look at this, or let's see, why is this happening? Okay, well, let's find this out. So
Yeah. Why did they go left instead of right? Just here.
yeah,
What was the one step before that, and you can kind of work it back.
yep. Yeah, and it was good, and it also helped that we had I had Microsoft engineers nearby if I needed help with something. It was like perfect. I've got
Yeah.
I've got people with expertise in all these areas. If we do actually hit a roadblock, I know they can either solve it or they can find me the engineer who can. Either way, it works. So, which was great.
Yeah, that's kind of pretty much what most of my kind of work is at the moment. I mean, one of my kind of current projects at the moment, we've been kind of literally on the production line, getting everything ready to kind of literally ship out the door to the customer, and it's like, oh, but this unit just failed a test. And it failed it in a most spectacular way. It's like something must be wrong, and now we've got to pull everything back and retest everything. And yeah, I think I've been through about 12 different iterations of we're just about ready to deliver, and oh no, there's one little thing, and yeah, and then you have to spend like a week trying to debug. Yeah, like you say, from kind of the wrong output back to where it kind of gets, and why did it go that way in the first place, and then oh right, was that little thing will go and turn this other switch on, and now you've got the right config. Try again.
Yep.
Gets all the way up to the end. Oh no, now there's another one, and that flag you just turned on to fix the first bug now causes another bug because a different flag is, yeah, now
Yeah.
needs to be inverted. And it's just just
Yes. Yes.
yes. Feature toggling is hard.
100%. That's one of those areas where I think people who go into engineering often don't realize the level of you have to enjoy problem solving and a certain level of frustration. If that doesn't excite you, this is probably not the field for you. Because there is
Yeah.
absolutely that level of it's not always pure frustration, but there is times where it's it does feel like kind of banging your head against the wall going, why will this not work? Kind of like the 3D printers, like the Enders, like they are very much the hobbyist tinkerer type printer, right? Some people just want the 3D printer where they want it to work like the regular paper printer where it's I hit print, out comes pretty thing. It's like 3D printers are not quite that way.
The bamboo lab, yes.
Yeah.
That's kind of the closest thing I think at the moment.
Mm-hmm.
I've got one of those as well.
Oh yes.
Yeah.
My boss has one.
The
They're
only reason
very
I've got that-
nice. But they are
Yeah.
very much the I hit print and I come back later and magical model is now printed.
Yeah, I had to get one because well, I say I had to get one. I bought it for myself last Christmas. It was my Christmas present to myself.
Wonderful.
And I kind of got it because the Ender requires an awful lot of work to kind of keep it maintained and keep it running, and it always changes, and it's and because I've been printing a lot of stuff for work. I mean, my son, he was like, oh, I want a stormtrooper helmet. So I started printing that on the Ender, and it was just like, 6 weeks later, I finally got all the bits, and I've actually got to a point where I'm almost finished that. I'll have to send you a picture of that at some point. And yeah, it's like this stormtrooper helmet, and it's taken me so far 4 years just to kind of print it and build it and
Yep.
sand it and spray it and put all the bits together and everything. And yeah, and in the where I've kind of worked now, pretty much just before that Christmas, they bought the new Bamboo Labs, the engineering version, the kind of
Mm-hmm.
the business version, as you could probably call it in air quotes.
Yeah.
Yeah,
The
it's and then
enterprise
they bought
grade.
this thing, and they just push stuff to it, and boom, a couple of hours later, there's a thing. Yeah,
Mm-hmm.
and somebody put my ender to shame by printing out the exact same 3D helmet that I just spent 4 years making, and printed it in about 8 hours, all in one, in this one printer. It's like, damn.
It's like, yeah, I need one of those.
So naturally, I bought it for Christmas for myself.
Of course.
Yeah, and now my son wants 5 more
Oh,
Stormtrooper helmets, just with slightly different colours,
of course. Of course.
and the Darth Vader helmet, and yeah.
Oh man. See, now you can crank him out in 8 hours. He's gonna start expecting them a lot quicker.
Yeah, as well as all the other stuff. I mean, like I said, since I've got this, because it's now one of those kind of just push a button,
Mm-hmm.
send the model, it just does it. And yeah, now all I've got to do is just put the little pieces together. Is
Yep.
I've he's kind of reverted, kind of rather than at the end of the school year, give a chocolate to the teachers to say thanks for the school year. No, they now get something 3D printed.
Of course. Of course. It's probably gonna end up being then very unique, right? You're now not the same as every other kid in the class. You've got something that's that's a little more,
Completely different, yeah.
yeah,
Yeah,
special.
I mean, yeah. So for kind of the end of the last school year, my son did. Um, it's like coffee mug, the coasters that you put your
Yep.
mugs on, and a coaster holder, but they're basically vinyl records and then a record player that they stack on.
Okay.
It's
Very
absolutely
cool.
brilliant. But yeah,
Yeah.
and it's like nobody's ever going to have that as a present. But it's just really interesting because, like I say, I mean, my son's kind of autistic, and
Mm-hmm.
just watching him watch the printer is just he, he loves it.
Yeah.
Yeah.
I mean, even me when I first got my ender running, like there was times where I would sit there and just watch it go. It's like this is so cool. It's like it's something fun about watching it, especially if you're doing if I'm doing like an 8 hour print, I'm not going to watch it. But if it's like a 15-minute print, sometimes it is fun to actually like watch it
Just
build up. It's
me-
like, oh,
yeah, it's just mesmerizing just seeing it kind of fill in and then zip about doing all the little
yep,
spider webs.
yep. Yeah, no, it is. I've been a little scared to get mine back up and running ever since I moved because we moved, it was chaos. We were remodeling, it was chaos. And now I finally have a spot for it. And I'm like, oh man, I'm going to have to redial it in and redo all the settings because when we, yeah, Victor's comment, watching the printer is hypnotizing. I agree. The when we moved, I very intentionally put the printer like front seat of my car, buckled it in, drove it over. I'm like, nope, I'm gonna do everything I can to avoid. I was like, because I had it so well dialed before we moved. I was like, I know there's no way to pick it up and move it without risking that calibration in some way, but I I tried my best. And after
Just needs to go into a great big lead lined box.
correct,
Yeah.
yeah.
So nothing can.
Well, and when we moved the new house, there was this large sheet of metal that they were using to cover a hole in the floor that I've since fixed. But I saved the sheet of metal because it's about the right size for my ender. Because before I always had the issue of the vibration and whatnot, and I've seen people get like slabs of marble or similar to kind of set them on to give them a firm base. And so my plan is to take that sheet of metal and lay it down because it's about the right size and it's fairly beefy. And I was like, okay, that'll give me a nice solid foundation that hopefully won't vibrate too much. Hopefully, we'll see. But I'm scared to fire it up. I'm like, I just know I'm gonna. The night I fire it up, I'm gonna immediately waste 3 hours recalibrating it and going back through and leveling the bed, and I'm not looking
That's
forward to
that's
it.
that's just the first step though, because once you've got the bed level and stuff, you don't have to worry about, oh right, what are now all my filaments wet and,
Oh yes.
and
I mean, I do have a drying
do
box
I have
that
to
I
recalibrate the
yeah.
nozzle now for
Oh yeah.
that's a pain.
Yeah, switching the filament between the different ones, like TPU is always the bane of my existence. I love the output of it. I hate calibrating in for it. It's so much of like I see people do it really nicely. I'm like, boy, they have a lot of skill with their printer to pull that off. I I spend a lot of time tweaking and getting it just right before it goes, and I'm not looking forward to it. There's been times where my wife is like, I kind of regret getting you the printer. It causes you so much stress. I'm like, I know, it's frustrating.
But it's fun.
I like the output, and I like once I get it dialed because it makes me feel it's like when you launch a pipeline and you've got like a dozen agents all take off to do the work for you. It feels powerful and nice. I get the same high when I have the printer dialed and I'm just cranking stuff out. It's like, oh, I love this so much. I feel smart. I got it to the right point. Doesn't always work
Yeah.
that way.
Yeah, I mean, my end is always kind of a, you do about 5 prints and then you have to start again
Yeah.
because something has stepped out somewhere or.
Yep. You've got something slightly off. And that was what I really loved before we moved is because I've replaced the springs and the knobs on the bottom of my bed because I don't have the auto bed leveling or anything fancy. It's all done by hand. But I had gotten my bed leveling set to where um, the plastic sheet that I have sitting on top of it, I can pop it off, flex it, get the model off, lay it down flat, and I had the corner set just perfectly to where if I laid it right back down, the next model was almost guaranteed to lay out exactly where I wanted. I was like, oh, I love this. I've got it perfectly lined up. And now I have to go and redo all that again. I'm like,
No, if you're going to go through that trouble, yeah, it's kind of, I'm almost at the point where I've got to rebuild one of mine because I've got 3 of them now.
of course, they do multiply.
But one of them is kind of in a state of disrepair. And I keep putting it off because it's like, well, I don't really want to go through all the hassle of setting just that one up and whatever. A little while ago, I actually bought the conversion kit to make it a Core XY, so very similar to how the like the Vorons and the Bamboo Labs one kind of work,
Yep.
with kind of their motions. And I've got that conversion kit, and it's just like, now do I just fix it or do I put that conversion kit on? Do I make it a completely different thing so it's like a Franken box? Yeah.
I think the latter. Absolutely. Absolutely.
Yeah, but then my kind of software side kind of kicks in. It's like, well, only change one thing at a time,
Yeah, that's
and
true.
then run a test, and then change one thing and do a test. And then it's like, no, but I want all of these things at once.
Yep. Yep.
Yeah,
Let's see. Ring setting, ABC, initial position, ABC, ciphertext, DIXSD. Oh boy. JC's got a whole thing plugged into here. Now I have to go convert this. Hang on. I think I've got Enigma. I guess. Hang on one second. I'm gonna pop the screen. Nope. I need to do. I really got to set up a separate one so that I can do this better without doing it. But let's go here. Okay, JC. I'm scared, but I'm doing this anyway. Let's see. Ring settings. A, B, C. Initial position A, B, C. Let's see if I can get this right. And let's see. Apply settings. And then, oh, it's going to make me actually type out the ciphertext. Won't let me paste. I thought I could paste in here. Can I not paste? Oh, that's so disappointing. Okay, well, let's see where we get to. D-I-X. Why isn't it? Oh, these are the plug board. Oh, hang on. That's why I'm going wrong. D-I-X. S-D. Oh, I see where we're going with this. E. E. Z. X. B. Z. See. Morning and oh boy. Let's see. X. S. O. B. C. And happy. Let's see. L. N. L. R. And happy Christmas. Thank you, JC. I love it. I love it. Though this is a beautiful example of, I guess, the, what did you refer to it as? I keep wanting to say symmetric encryption, right? Where even though the encryption text there, you put the encryption text in here with the same settings, the ciphertext then translates back the other direction.
Yeah. So that's exactly what the symmetric is. Yeah, it's using your original text. You can create the ciphertext, but using the ciphertext with the same starting point and settings.
You can go right back the
Yeah,
other direction.
it goes backwards. Exactly the same as how the Caesar cipher works. Kind of, yeah. If A goes to B, then B actually has to go to A.
Mm-hmm.
So you can do it forwards and backwards.
Yeah. Oh, so exciting. So exciting. In retrospect, I probably should have fired up my own app and done that, but
So I'm just waiting for once we kind of get the basics done and yeah, an actual machine to run it on. Actually having the kind of the Raspberry Pi compute bit added into it, whereby actually I'm going to write some text and now I'm going to zip it up and base 64 encode the bits, and I'm going to encode, yeah, run that Caesar cipher on effectively the base 64 zipped up
encoding.
file.
Oh. Yeah, because I
Yeah.
guess that should be very doable. I think all we have to do is expand out our character set to handle all of the stuff in the base 64.
Well,
Right?
it's just kind of a handoff between the keyboard and whatever the first kind of component is. It would
Yeah.
just kind of batch up the whatever the input is,
Mm-hmm.
then kind of binary because you can. I believe there's kind of a way to kind of do encryption on a stream in .NET, and therefore you
Yep.
can kind of get, well, I put all these characters in, and actually the output I can just read it off bit by bit when it actually comes off as, you know, in its words, yeah, each kind of character
Mm-hmm.
of the encoded value, and then you run that through your base 64, and you can kind of do it all effectively as a stream. I've done similar kind of things with a little library I did in my previous role. Yeah,
Okay.
which we kind of dubbed the data store framework, which was if you think of kind of data kind of transmission,
Mm-hmm.
storage, um, but with kind of a library similar to kind of mass transit as it would be for messaging.
Okay. Yeah.
If you've done anything like that, so I wrote a library that did that, but for data storage.
Okay.
And this is kind of where something like that might kind of sit in the middle, which would be quite cool.
Yeah.
And then after that, then it's kind of a, well, actually, now I want to take, yeah. In the olden days, they would have sent these encoded messages via Morse code, you know, dots. So actually having maybe some kind of audio input where actually you can do the dots and dashes and actually do it, convert this kind of audio into the binary ones and zeros
Mm-hmm.
and yeah, I've got loads of ideas for kind of extra kind of attachments and accoutrements.
It's funny you say that because I actually saw somebody demo Morse code with I think it was Azure AI Foundry converting it through. I was like, of all the weird demos, I was like, now that's kind of cool. I had not considered doing this, but now that you say all of that, it does make me think that it would be kind of cool to take some of that Enigma stuff that we wrote into the library, and I'm trying to remember what the, because in .NET, uh, what is the, there's a base class that you can derive from, and I'm assuming this is what you would ended up doing. Crypto transform, that's what I'm looking for, or crypto stream, and I imagine we could basically write our own implementation to be able to, because at the end of the day, it does just transform blocks of bytes.
Yeah. Yeah, and then you've essentially got that same kind of thing. So you can actually have the stream coming in. It's like, actually, I want to send this file and
Mm-hmm.
encode this file in the same kind of way, or a photo, an image of some sort. And actually, I'm going to send that down the wire. Yeah,
Yeah.
and it kind of opens up not just having the keyboard, but now I can actually send the files in the same way and do
Yeah.
some really cool extra kind of bits and bobs to it.
Yeah. This one could be kind of fun to implement. Just, again, just kind of for kicks and giggles. But it would be an interesting idea to go through and have your own iCrypto transform that Enigma encoded your bytes. Because you'd obviously have to send in the effectively what you were talking about with the let's see, would you call it system config or similar, of how to kind of set all of that up so that it would know the appropriate transform. But after that,
Well,
would
yeah,
not be
I
difficult.
mean, I'd kind of see it as being, I mean, you could probably use generics in a way where you'd have um, kind of your transform that really just uses a machine
Mm-hmm.
to do the transform, and all the legwork's actually done by um, the creation of that machine using
Okay.
that kind of type as a, um, yeah. Is
To
it
be
the
able to,
type 1? Is it the type 2? Is it the type X? Is it,
right, to
yeah?
know that kind of
Is
setting all
his
the way through.
is his mad laboratory?
Yes, is this Izzy's modern version? uh,
Yeah, yeah, and then like I say, once you kind of get to that point, then why not go kind of one step further and actually you kind of got your encoded bytes, maybe um, maybe you've converted it into some kind of Morse code
mhm.
style dots and dashes, but actually now maybe I want to send that physically over HTTP or TCP or UDP and actually have my own custom kind of Enigma packet and send it down a network wire. Yeah,
Oh.
there are just so many kind of different facets that you can do, not just with actually doing the encoding, but then
Mm-hmm.
it's like what kind of inputs can I take and what kind of, how can I transmit those between one point and another, and can I actually build two of these Enigma machines that just talk together? Just plug a pen drive in and just say send all that information from one side to the other.
Yeah.
And I don't actually have to push any buttons, but if I want to, I can send a normal message like I would on a typewriter.
Mm-hmm.
Yeah, in ye olde days.
Yieldies. Oh, yeah. Back, this form. Cool.
Yeah.
Well, Izzy, I may call it a little early tonight, given that I've been up now for going on 18 hours. So I may crash. So thank you for coming on and doing this. I really appreciate it. It's been fun. And this again, I love all of this World War II history, and getting to work on this is awesome.
Yeah, no worries. And it'd be kind of cool. Like I say, once we get to kind of having some of these things in place, we like I say, the part of the app that I think I've done the wireframes for it is pretty much kind of documenting kind of that history and different ways to kind of do that. So actually, when we kind of get to that point, delving into that would be really cool, I think.
Yeah, absolutely. Absolutely. Because again, even just going through and learning all of it would be fascinating and fun for me, and then writing all that out. So, well, cool. Real quick for anybody who wasn't around at the beginning, just a reminder: .NET Conf is coming up in a couple weeks, i.e., Geek Christmas, and all the happiness that comes from that. Free conference. Check it out. It'll be streamed both on the .NET Conf website as well as their YouTube channel. More importantly, Benjamin's talking, which Benjamin is an awesome guy. And then my user group session coming up in December of everything that is new in C# and .NET. Small teaser that I didn't mention earlier is there's also another conference that is going to be announced that's going to be free and online in December that I have to hurry up and finish recording my session for. But as far as I'm aware, it's not announced yet. But if you want a sneak peek, go look at what conferences I may have spoke at of December of last year, and that'll be your clue. Same one. Same last minute scheduling as well. So it'll be great. So that will be coming. And then I think the last one I wanted to plug was Dan's, let's see here, if I can grab it here. Do it without it blowing up my audio here. But Dan, another colleague of mine who, if anybody's watched the .NET stuff, has seen him. He is starting his own streaming. So absolutely check him out. He's doing a lot of .NET Aspire and Angular front end. So full stack development and building out a sample app there on his stream. So it's pretty cool. Izzy, once again, thank you very much for coming and doing this. And I am sure we will do this again soon, or maybe we'll do a pairing session or similar as we work through some more of this.
Yeah, that'd be good. Cool.
Awesome.
Merry Christmas to all, and to all a good night.
Sounds good. As always, everybody, happy coding. We'll see everyone next time. And I need to remember how to use my own stream.